In this video presentation, we're going to cover how to create an RJ45 connector. The dimensions that we need are the body length, which is 25.4, the body width, which is 16.2, and the body height, which is 13.3. Then we need to create our pad stacks. In this particular case, we need to create 4 different pad stacks. So I open up Footprint Expert, select Designer, and then I insert the package dimensions 25.4, tab 16.2, tab 13.3, and then I can set my body courtyard excess. Since it's larger than 10 millimeters, I'm going to put a 0.5 millimeter courtyard excess for the body. And we'll put our polarity indicators over in the upper top left. And same thing with the 3D model, top left. And we'll leave the base color black. Select OK, and it will open up the Pad Stack Designer. And in this particular case, there are just through-hole pad stacks. Go back to the datasheet, and I need a non-plated hole for these pegs. And I need to know the dimension from the edge of the body to the center of the peg, which is 10.8. It's an important dimension because everything kind of keys off that of those mounting holes. So there's 2 non-plated holes, which are 3.18. Then the shielding holes, which would be 1.63. Then plated through hole 0.89, and one for the LEDs, 1.02. The first mounting holes I'm going to put in my pad stack are going to be these. The first pole, I'm going to put in these first, then these second, then these third, then these fourth. So 3.18, create a non-plated pad stack. Plated hole, no. 3.18, enter, add to the queue. Then my next pad size is 1.63, and it's plated. 1.63, enter, add to the queue. My next hole is going to be 0.89, then 1.02. 0.89, enter, add to the queue, and 1.02 for the LEDs. Enter, and add to the queue. Now I'm going to add these 4 pad stacks to my design. And in the Pad Stack Manager, I have full access to edit anything that I want here. I can edit any layer in any pad stack, a solder mask, keep outs. So you have full editing access, but I'm not going to edit anything here because I got it all together. We're going to save and close. And I notice here that my body size is actually on its side. So I'm going to go back to the body tab, and I'm going to swap these 2 dimensions. 16.2 is this width, and 25.4 is the length. And select OK, and now it puts it up to match the data sheet. So I'm going to try to match the length of the part. The 0 component orientation should be the same as the data sheet. So when you look at the data sheet, you look at the footprint, they match. The first thing is the 10.8 from the edge of the body to the center of the So what we're going to do is we're going to move the origin, the first thing right off the bat. We're going to select the origin, and I'm going to select a line down here, which is going to be the component outline. Now, the assembly outline is mapped to the maximum dimension. Silkscreen outline is mapped to the maximum, but the component outline is mapped to the nominal. So I'm going to select the component outline. Then I'm going to select snap to midpoint and apply. Then I'm going to define the coordinates, and the coordinate in the y-coordinate was 10.8. 10.8 from this edge to the center. 10.8, apply, and then there's where my non-plated mounting holes are going to be. I select those mounting holes. Now these particular holes are just going to be M1 and M2. M1, and we're going to go ahead and slip in the coordinates. Now the y-coordinate is going to be 0. And the x-coordinate would be 11.43 as the span, and then the half of the span is 5.72. So we're going to start out with negative 5.72, and we're going to do the span, which was 11.43, and I'm going to step it by 1 in the x direction. Oh, y is 0. Sorry, 11.43 is step 11. So I add those two holes to the design. Now I select another pad stack. I'm going to select the next pad stack that we're going to put in, and this is going to be MH for mounting hole, because these are plated through holes. And I'm going to go back to the data sheet, and they are located at, if you go up 635 and go down 3.3 in the y direction, it is 3.05. 1574 is the span. So the step is 1574, and I just copied and pasted that from the data sheet. And the y direction is going to be 3.05, the math that we did. And it's going to be in the negative. Half of 15.74 is 7.87. And so we're going to add these two holes to the design, MH1 and MH2. Now, the next dimension that we need would be 635 to P1. Okay, so we're going to enter those dimensions here. And I'm going to go ahead and step this by 1.27. And I'm going to show you a feature here of stagger. We're going to stagger in the y direction 2.54. And I'm going to put in a negative 4.45. And then, of course, the y direction would be the 6.35. And these pin numbers are going to be, this is P1, P2, P3, P4, P through P8. So we're going to type in P for the pins, names, and add to design. Whoops, I have the wrong pad stack, and I have the wrong repeat. So we're going to undo that. We're going to pick the right pad stack, number 1. See, because we always use the undo button when we make an error. I'm going to put in 1, and I'm going to repeat 7 times. So I put in pin 1, P1 through P8. Okay, now we're going to go back to the origin and define coordinates, and we're going to go up to the 6.35 in the y. And we're going to move the origin up here because the next dimension is from that row, the P1 row, up to P9 and P10. So we're going to select the next pad stack for the LEDs, and these are going to be P, and this is going to be P9, and there's no step or stagger. We're going to step this at 2.54 in the X. We're only going to step it 1 time. And the coordinate's going to be 546 And by the Y is going to be 737 per our origin. That's per the datasheet. And P9, add to design, is going to add our first two LED holes. Then we're going to go back to pin names, and we're going to go P11, and we're going to add P11, and the X dimension is going to be 2.92, and select add to design, and it adds the other LEDs. Now we're going to go and collapse the pin placement menu. We're going to move the origin to 0, 0. So I'm going to take the origin and put it to the center of the body. Apply. Then I'm going to fill out my specifications. My description is going to be connector, and I'm going to roll down to RJ45, right angle. My manufacturer is going to be Molex, and my case code and my part number for all connectors are all the same. This part number is going to be 48025-0002. And I'm going to take that dimension and copy it down to the part number and select the part number for the footprint name. So it's going to be Molex and then the part number. Select OK. The green light lights up. Finish. Open up my library. I'm going to add that part to the library. And it automatically adds the footprint name, the physical description, the case code, the manufacturer name, and the part number. Now what I need is the logical description. And the logical description would be connector and the number of positions and the pin pitch. So we're just going to go ahead and drop that in there. The part is a through-hole part, so I'm going to type in T. It'll drop down to through-hole. And for the datasheet link, I'm going to go to the datasheet here and grab that link to that datasheet and put it in the datasheet column. And then save my library. Now you can click and drag this little bar up here so we can see that. And there is our RJ45 connector that we've created from scratch.
Simplify, standardize, and automate an entire IPC and IEC compliant library. Detailed, accurate, reliable, professional. Highest quality footprints and 3D step models, clicks away. Many companies worldwide are easily generating their CAD libraries. You should too. Get a fully functional Footprint Expert Evaluation license for any CAD format and demo today. Contact us at PCBlibraries.com or call 847-557-2300.